This is for Year 12 Specialist. It comes out of the Northern Hemisphere Specialist Exam 2 2017, question number 2. Okay, what are those roots of an quadratic equation with real coefficients? Therefore, the conjugate appears. Write down the other root. Well, the other root would be root 3 minus I. Determine the quadratic equation in terms of that, so we will have x minus root 3 plus I, close bracket, and minus I so it's going to be in the form of z squared minus 2 root 3 z plus 4. Plot and label the roots of this. Well, this is that times by z. So I'm going to have z minus root 3 plus I, and z minus root 3 minus I. Therefore I'm going to be at 0, and I'm going to be at root 3 minus I and root 3 plus I. Okay, find the equational line, that is the perpendicular bisector of the line segment joining the origin and the point. So we're looking at perpendicular bisector, and my perpendicular bisector will go through there. So the gradient of this line is going to be pi on 6. Is that correct? So what have we got? We have root 3 and 1, and the tan of theta is 1 on root 3, so that's pi on 6. The gradient is going to be 1 on root 3, and the gradient of my perpendicular will be negative root 3, and I'll go through this point here, which will be half. So that will be root 3 on 2 and a half. So it will be y minus 0.5 equals negative root 3 x minus root 3 on 2. And solve for y. And I'm going to get y equals negative root 3 x plus 2 is the equation of the perpendicular bisector between those 2 points. Part D, the 3 roots plotted in part B lie on a circle. Find the equation of the circle expressing it in this form. Okay, so they're there, there, and there. Where that's root 3, 1, that's root 3 minus 1, and that's 0, 0. The circle, if it goes through those 3 points, must have its centre which is on the x-axis, because these are vertically on top of each other, therefore the centre of it must be on the x-axis. So that will be R, and that will be R, and that will be R. So the centre of the circle will be at R0, and the radius will be R. So I've got x minus R squared plus y squared equals R squared, and then I can sub a point in. So x is root 3 minus x, I'll use x for r, plus y squared, and y squared is 1, so that's 1, equals x squared. And solve for x. So that's my radius is 2 root 3 on 3. Therefore, alpha equals beta, so it's z minus 2 root 3 on 3 equals 2 root 3 on 3 is the answer to part D.